Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is derivative of a radical function. If you have studied calculus, you undoubtedly learned the power rule to find the derivative of basic functions. However, when the function contains a square root, radical sign, the power rule seems difficult to apply. So using a simple exponent substitution, differentiating this function becomes very straightforward. You can then apply the same substitution and use the chain rule of calculus to differentiate many other functions that include radicals. First, let us have a review of the power rule for derivatives. The first rule you probably learned for finding the derivatives is the power rule. The rule says, for that a variable x raised to any exponent, the derivative is as follows. For example, review the following functions and their derivatives. First, I am going to take x square. Derivative of x square is just 2x. For example, if you take f of x as 3x square and its derivative would be 2 times 3x, which is equal to 6x. Am I right? Let me take one more example. Please look at this function. It is 1 over 2 x raised to 4. Then what would be the derivation? Yes, 4 times x raised to 3. You have to just multiply it by 1 over 2 because this is a coefficient. You can just take it outside. You have to take all the constants outside and apply the power rule only for the variables. So the first derivative of f of x would be 2x cube. Am I right? We are going to see the same concept in the square root because square root can be written as an exponent. To find the derivative of a square root function, you need to remember that square root of any number or variable can be written as an exponent. Okay, I'll show you the term below the square root sign is written as the base and it is raised to the exponent 1 over 2. Both are same. Square root of x is equal to x raised to 1 over 2. For example, let me take some number instead of variable. Square root of 4 is 4 raised to 1 over 2. Okay. Now let's apply the power rule for the square root. If the function is the simplest square root, for example, f of x be square root of x, by applying the power rule, we can find the derivative easily. I'm just shifting the power to the coefficient's place and subtracting 1 from the exponent. So rewriting the radical as an exponent is the first step. And then find the derivative with the power rule. So half minus 1 is nothing but negative half. So you can rewrite it as simple. You can simplify it as an exponent. Our answers will be considered as an incomplete one in case if you give a negative exponent term. So how can we change this negative exponent? In case if your numerator has a negative exponent, you can shift the term to the denominator. So that by doing so you can change the negative exponent into positive exponent. Here I am just going to shift it to the denominator. Finally, you can just rewrite the exponent as square root. So 1 times 1 is 1, 2 times of x raised to 1 over 2 is 2 times x raised to half, which is nothing but 2 square root of x. So at this stage you need to recognize that a negative exponent means to take the reciprocal of what the number would be with the positive exponent. The exponent of negative half means that you will have the square root of the base as the denominator of the fraction. So continuing with the square root of x from this, the derivative can be simplified as 1 over 2 root x. So far we saw how to apply the power rule. Now we are going to review with the chain rule for the function. The chain rule is a rule for derivatives that you use when the original function combines a function within another function. Hope you remember our previous video, function of a function. The chain rule says that for two functions, for example, let that be f of x and g of x, the derivative of the combination of the two can be found as follows. For example, consider a function y equal to f of g of x. This is just an example I have taken to denote a function within another function. So what would be the derivative of this one? F dash of g times g dash of x. Am I right? Now for this example, let us find the derivative and apply the chain rule here. To use the chain rule requires that you first define the two functions that make up your combined function. So for the square root function, the outer function is f of g, will be the square root of function, and the inner function g of x will be whatever appears under the radical sign. So for example, if you are choosing this function, we wish to find the derivative of a square root of 3x plus 2. Define two parts as follows. First, f of g is just square root of g. Hope you know that we can rewrite square root as exponent 1 over 2. And g of x is nothing but the function under the radical. So g of x is 3x plus 2. So to find the derivative of the two functions, we have to apply the chain rule to the square root of a function. You will first need to find the derivative of the general square root function. So f of g is square root of g, which is nothing but g raised to 1 over 2. So what would be f dash of g? Yes, half times g raised to negative half, which is nothing but 1 over 2 times square root of g. Then find the derivative of the second function g of x. G of x is 3x plus 2. So g dash of x would be nothing but 3, because derivative of a constant is just equal to 0. So this term vanishes. You have to find the derivative of the first term only. So that would be 3. Now we are going to combine the functions in the chain rule. Hope you remember the chain rule. I'll just write the rule on the board. So all you have to do is substitute the values we got for f dash of g and g dash of x. You just have to plug in 1 over 2 times square root of g times 3. So that would be 3 over. Please make sure that you substitute back the value we assume for g. So g is nothing but 3x plus 2 here. So by replacing, we will get. That's it for this example. Hope you're clear with the application of chain rule in the radical function. Okay, I'll let you know a shortcut for the derivatives of radical functions. Let us learn the shortcut for the derivatives of any radical function. So whenever you wish to find the derivative of a square root of a variable or any function, you can apply a simple pattern. The derivative will always be the derivative of the radicand divided by double the original square root. Symbolically, this can be shown as, okay, for example, f of x be square root of any function u. Then f dash of x is nothing but u dash, okay, divided by 2 times square root of u. Derivative of the radicand divided by the double the original square root. Does this make sense to you? Let us try to take an example and apply the same concept. Okay, we are going to find the derivative of the radicand. Radicand is the term or the function underneath the square root sign. To apply the shortcut, find the derivative of the radicand alone. So consider this example. In this function, f of x is square root of 5x plus 2. And here the radicand is 5x plus 2. Am I right? And what would be its derivative? Yes, its derivative is just 5. So u dash is derivative of the radicand, which is nothing but 5, divided by 2 times the square root of the quotient itself. To differentiate a function containing a radical, replace the radical by a fractional exponent. And then find the derivative by applying the appropriate techniques. Okay, let me take one example and explain you again. So far we discussed examples with a radical in the numerator. Now I am going to take one example where the radical is in the denominator. Here is the next example. We have 2x plus 1 in the numerator portion, and in the denominator we have a radical which has 3x square plus 2 underneath it. So first replace the radical by the proper fractional exponent. So this can be written as, we know that square root can be written as exponent 1 over 2. So at this point a decision is in order. This problem may be solved by either writing f of x as 2x plus 1 over 3x square plus 2 raised to 1 over 2, or by just applying a theorem. So in the denominator and then applying another theorem for the quotient. So this can be written as, I'm just going to shift this to the numerator. If I shift so, the positive exponent will change into negative exponent. Am I right? The theorems I mean here is the quotient rule and the product rule. So if you are writing it as a product, you can apply the product rule. Or if you are keeping this as it is, then you can use quotient rule. So it is purely depending upon you, your convenience. You can choose the method that you are very comfortable with. Okay, first let us start with this one. In case if you are going to use the quotient rule, you have a numerator and a denominator. Keep the denominator as it is, find the derivative of numerator. Keep a negative sign in between, keep the numerator as it is, and then find the derivative of the denominator divided by square of the denominator. Square of the half is just the 3x square plus 2. Am I right? So this is the answer you would get if you apply quotient rule. You can simplify it further if needed. Until unless mentioned in your question, you need not simplify it. And this will go. Now let us see what will happen if we apply the product rule. This is case 2, this is case 1. In case 2, we are just rewriting the same thing as a product. And if you are going to apply the product rule, you have to find the derivative of each factor. So this one would be 2x, and derivative of this would be negative 3x, times 3x square plus 2 raised to negative 3 over 2. I'm just applying the power rule for this one. So this would become, okay, keep the first function as it is, find the derivative of second function, plus sign in between, keep the second function as it is, multiplied by derivative of first function. So this is called product rule. Multiply both numerator and denominator by 3x square plus 2 raised to 3 plus 3 over 2. So f dash of x would be, so by doing so you brought the exponent, the negative exponents to the denominator and you made it common. So you can just distribute these and combine the like terms. So if you distribute, you will get, can you follow so far? Okay, even you can simplify it further. So the top row can be simplified as x square and x square gets cancelled out and you'll be left over with 4 and negative 3x. You need not write a negative number as a starting one. So you can just write it as 4 minus negative 3x. You'll get the same result even in the previous method if you simplify this solution. Does this make sense to you so far? So while you're dealing with radical function, you can replace it by the exponent 1 over 2. So depending upon the type of the question that you're getting, you can apply the corresponding rules. For example, you can apply power rule if the question is of that type, or you can use a product rule or quotient rule depending upon the question that you're getting. So if it is in the quotient form, I mean in the division form, you can apply quotient rule. If two functions are multiplied with the radical, then you can apply the product rule. It purely depends upon the questions that you are getting. Hope you are clear with this video. In case if you